This is section 5, topic 10. We worked on section 5, topic 10 yesterday as well. But yesterday we solved a system involving a circle and a line. We solved it algebraically. Today I'm going to show you how to solve a system of an equation, or of a circle and a line. I'm going to show you how to solve it graphically. Okay? Remember to put your name, not mine. People keep putting my name and I don't know who to give credit to. And the topic is systems of equations involving a circle and line. Bless you. And the essential question is, how do you solve a system of equations involving a circle and a line graphically? Again, we know how to solve a system of equations involving a circle and a line algebraically. We learned that yesterday, where you isolated for the line function, you isolated the y, and then whatever y was equal to, you substituted that into the circle equation. Remember that? So we learned how to do it algebraically yesterday. Today we're going to learn how to solve it graphically. All right? So first thing we need to know is the general form of a circle. Is, open parentheses, x minus h quantity squared plus, open parentheses, y minus k quantity squared equals r squared. So the equations that we had yesterday of a circle, they didn't look like that. They were like x squared plus y squared plus 2x minus 3y plus 9 equals 0, right? They look something like that. They were not in general form, okay? And the problems that I'm going to give you today are going to look like yesterday's. We're going to convert them to general form because they're easier to graph when they're in general form, all right? You know, like if you have an equation, a line that's in standard form, ax plus by equals c, if we want to graph it, we convert it to slope-intercept form because it's easier to graph that way. Circles, same thing. General form, much easier to graph. If your equation is in general form, you will know what the center of the circle is. Your center of the circle is at h comma k. So that number that's with x, that's going to be the x value of your circle. The number that's with y, the k, that's going to be the y value of the circle. Now notice in the formula it changes the sign of h and k, it subtracts. So if h was started as 4, it's going to look like a minus 4 in the equation, right? If k started as 2, it's going to look like a minus 2 because it'll be y minus 2. So you got to remember to change the signs. All right, so put yourself a little note, change the signs of h and k. And And you'll also know the radius. Whatever this constant is, that is your radius squared. So say that was the number 16 there, then your radius would be 4, because this is the radius squared. So the square root would be the radius. So if it was 16, your radius would be 4. This will all make more sense when we actually do it, okay? So in my first example, we're going to solve by graphing. And our system is x minus y equals negative 5. And is that our linear equation or our circle? That's our linear equation, right? That's going to make a line. And the other equation is x squared plus y squared minus 10x minus 12y equals negative 45. And that's going to be the equation of a what? Circle. We call it a conic equation, but circle is a type of conic. This particular equation is a conic that is a circle. Okay? You'll get more into conics and stuff. I think you did that in geometry. If you do pre-calc, you get more into conics. Okay, so the first thing we're going to do, we're going to graph these. So my line, bless you, is in standard form. It'd be easier to graph it if it was in slope-intercept form, right? Right, Miss Riley. So the first thing I'm going to do, and you can either deal with the circle first or the line first, it doesn't matter. But the first thing I'm going to do is I'm going to convert the linear function into slope-intercept form. And maybe it is already, but if it's not, I'm going to convert it. And remember, slope-intercept form is y equals mx plus b. So basically, I've got to isolate the y. So let me write that down. X minus y equals negative 5. What should I do first? Subtract x from both sides. So x minus x is 0. I'm left with negative y on the left side. And these are not like terms. Slope-intercept form would put the x first, so minus x minus 5. Is that slope-intercept form? No. No, what do I need to do?
Change the signs because y can't be negative.
Right. So I could divide every term by negative 1 or multiply every term by negative 1. Either way, I'm going to get the same thing. So that would give me y equals x plus 5. So I'm going to graph that. What's my y-intercept in this function? Anybody?
It's going to be 5.
5. And what's my slope?
1 over 1.
Positive 1, right? Okay. So go ahead and draw your little x and y intercept over there, and we're just doing one problem on this page. Where my ruler went. Oh. So we plot the y-intercept first. It is at positive 5 on the y-axis. and my slope is at +1. A positive slope is a positive interval. So if you keep getting confused about that, if I go up 1 to make a positive slope, but I go left 1 or right 1? Right. And I don't know where these intersect, so I'm going to be very accurate, and I'm not just going to go up 1 and right 1 one time. And if I go down 1, I'm going to go left 1. So remember, when we're solving a system, we are trying to find the ordered pair or pairs they have in common, if there are any. Last class I taught you how to do it algebraically. Today I'm showing you how to do it graphically. And we don't have a compass, so the circle is going to be kind of challenging. This is why graphing's not always the best idea. Okay, so we have one of our functions graphed, the line. Now let's graph the circle. To do that, we're going to convert the circle to general form. Which general form is what we wrote at the top of our notes. We had x minus h quantity squared plus y minus k quantity squared equals r squared. Okay? That's not what form it is in right now. I'm going to show you how to do that. You need to know how to complete the square to be able to convert this to general form, but we know how to do that. So, yay. So what you do is, first of all, make sure your constant's on the right side. If it's not already, move it. In this case, our constant is on the right side. Okay, so we're good to go there. So what we're going to do, I'm going to make 2 sets of parentheses with a plus in between them, equals whatever that constant is. I'm going to group my x's in the first set of parentheses in standard form, so I have x squared minus 10x, and I'm going to kind of leave myself a little space because I'm going to make this a perfect square trinomial. Not yet, but I'm going to. In the next set of parentheses, I'm going to group my y's together in standard form, so I had a y squared minus 12y, and I will be finding some number to put here that would make this a perfect square trinomial. Okay? So, I'm not trying to solve for anything. Usually when I complete the square I'm trying to solve, I'm not trying to solve, I'm just trying to put this in general form. Okay? So, in my first set of parentheses, I got to figure out, okay, what can I put here that's going to make this a perfect square trinomial? Remember how to complete the square? We do b divided by 2 quantity squared. So in this case, my b is -10, right? So that would be -10 divided by 2 quantity squared. What is -10 divided by 2? -5 quantity squared is what? 25, okay? So I'm going to add that number to the left side of the equation, and on the left side, I'm only adding it into that first set of parentheses, but I have to remember to also add it to the right side. And before I simplify that, I'm going to figure out what needs to go in my other parentheses to complete that square as well. So over in that side, b would be -12. So So negative 12 divided by 2, quantity squared. Negative 12 divided by 2 is negative 6. Negative 6 quantity squared is 36. So on the left side, I'm going to add it. I added it to the left side, but where I'm going to place it is in the parentheses of the y. Don't forget, I also have to add it to the right side. Okay? So now let's see what we have. So over here I have x squared minus 10x plus 25, close parentheses. There's a plus sign in the middle. On the right side I have y squared minus 12y plus 36, close parentheses, equals, I have to do negative 45 plus 25 plus 36 is 16. So I created two different perfect square trinomials. I'm not solving for anything. I'm just converting it to general form. Why do you think I wanted to create those perfect square trinomials? Do I know how to factor a perfect square trinomial using a shortcut? Yeah. Notice up here, if that was like x minus 4 quantity squared, wouldn't that look like the factor of a perfect square trinomial? If that was like y minus 2 quantity squared, wouldn't that look like the factor of a perfect square trinomial? Yeah, so I did that so that I can shortcut factor both of these. So this is a perfect square trinomial. To factor it, one set of parentheses and square it. What's going to be my sign? What? Minus. It's whatever b is. What's my first term? X, because it's the square root of the first term. What's my last term? 5, because it's the square root of the last term. Okay? Bring down that plus sign that goes in the middle. Over here, because we completed the square, we also have a perfect square trinomial. So let's factor it. We know it's going to be two identical factors, just like this was. So since it's two identical, we make one set of parentheses and square it. So what is going to be the sign in this factor? It's also minus. It's whatever b is, right? What's my first term? Y. It's the square root of the first term. What's my last term? 6. It's the square root of the last term. Equals 16. I'm not solving it, okay? Does this look like the general form of a circle? Yeah. This is x minus h quantity squared plus y minus k quantity squared equals r squared. That's the general form of a circle that we have written down at the top of our notes, right? We need that to graph a circle. All I got to know is where the center of the circle is and what's the radius, and I can graph it. Okay? So remember, the center is at h comma k, but you got to change the signs because the minus sign, it makes it look opposite of what it started as. So where do you think the center of the circle is? 5 comma 6. Your h looks like negative 5, so we know it was positive 5 to begin with. K, it looks like negative 6, so we know it was positive 6 to begin with. H comma k is your center. What do you think the radius is?
4.
It's 4. How did you get that? Right, because this is your radius squared, so we got to take the square root to figure out where your radius is, or what your radius is, not where it is. Now we can graph that circle. Okay? What do you think we plot first, the radius or the center? Yeah, center. So if you need to see this, I'll give you my paper when I'm finished. Let me go on up, and I'm going to plot the center of my circle when x is 5, y is 6. So for the radius, I'm just going to go straight up from the center, straight down to the left and to the right. I'm not doing any diagonals. I'd have to do a lot of math to figure that out, okay? So I know, y'all remember what a radius is? Circle's in the middle and the radius is from the center to the outer edge, right? So from the center, I'm going to go 4 units to the right. I'm going to go 4 units up. Right there, I already see a point that they have in common. I'm going to go 4 units to the left. There's another point they have in common. And I'm going to go 4 units down from the center. And although that looks like a parallelogram, we got to make it look like a circle, which it's kind of hard without a compass, but I don't have any compasses. So I'm going to do my best to make it look like a circle. It's not very pretty, but how many ordered pairs do this line and this circle have in common? 2. Those 2 ordered pairs are the solutions. If I would have solved this algebraically, I would have found the same thing, okay? We can't just show the graph. We have to say what the solutions are. So this one is 1, 6. And this one is 5, 10. Those are my solutions. Graphing is not always the best method, all right, if you don't have a graph, or sometimes you kind of have to estimate where they intersect, and maybe your circle's not perfect. So if you don't have a compass or you don't have graphing technology, I would probably solve it algebraically if you need to know an exact answer, right? If it was multiple choice and you could do a little estimating, then cool. But otherwise, it's not always going to be the most helpful. If you have graphing technology, great. Plug it in, put in your equations, and you can find it easily. But if you have to do it by hand, you got to be very tedious, and again, you might be doing some estimating. Okay? So let's do another example on this. Backside, example 2. We're going to solve by graphing again. And my equations are, by the way, is a circle a function? No. I think yesterday when we did the notes, I might have said on the recording, I might have called a circle a function. I might have said we need to graph these functions, just not thinking. Circle is not a function. The line's a function, circle's not a function. X squared plus y squared minus 3x minus 3y minus 20 equals 0. And the other equation is x plus y plus 4 equals 0. And I want to solve these by graphing. It does not matter which one you graph first. I'm just going to start with the line, okay? So I'm going to take my line, and that's not in any particular form. I'm going to convert it to slope-intercept form. So I need my y to stay positive. It's already positive. I know the easiest thing to do is to move it over to the right, but then it's going to be negative, which is fine, but then you got to get rid of that. So I'm just going to move the 4 and the x, and I'm going to move them at the same time. So I'll have to subtract x, and I'll have to subtract 4 from both sides. So x minus x is 0, 4 minus 4 is 0, so I'm left with y on the left side. On the right side, negative x, and 0 minus 4 is negative 4. So what's my y-intercept? Negative 4, and what's my slope? Negative 1. So I'm going to go ahead and graph that. You can wait and graph them both at the end. That's fine. I'm just going to go ahead, get the graph going. So my y-intercept is at -4. Slope is at -1. So I know it's going to be a decreasing interval. That helps with knowing whether I go left or right. So if I go up 1, would I go left or right to make a negative slope? Left. Or I can go down 1 and to the right. Everybody cool with that? So that is a function. The line's a function, passes the vertical line test, right? The other equation we know is a circle because you have an x squared and a y squared. If it was just an x squared and y had 1 degree, then it would be a quadratic. But x squared and a y squared makes a circle. Circle is not a function. And that circle is not ready to graph. We have to get it in general form. So on the last example, that constant, all of our constants were on the right side. In this example, that -20 is a constant and it's on the left side. We need to move it with the other constant on the right side before we do anything else, okay? So I'm going to add 20 to both sides. And then I'm going to have 2 sets of parentheses with a plus sign in the middle. The first set of parentheses, I'm going to group my x terms together. And the second set, I'm going to group my y terms together. So in the first set, I have x squared minus 3x. And I'm going to be completing the square, so I'm going to have some number to put there. Plus. And the next one, I'll put my y terms together in standard form. So y squared minus 3y. I'm going to leave myself a space to remember I'm going to be finding a number to go there, equals 20. And remember, when we complete the square, a needs to be 1. In both of our cases, a was already a 1, so we didn't divide every term by a. And I'm not going to give you any on the circles that a is anything other than 1, okay? I don't want to complicate it that much. We're good if we know this much involved with how to graph a circle, okay? So, and sometimes you're going to have fractions and decimals. That's okay. When I complete the square, notice the b in both of the equations is the same thing. Okay, so that's cool. We only have to do that b divided by 2 quantity squared once. So b divided by 2 quantity squared. b is -3 divided by 2 squared. And that's not going to divide evenly, but it will be a terminating decimal, so I'm going to turn it into a decimal. I'm going to turn that into -1.5 quantity squared. And -1.5 quantity squared means -1.5 times -1.5, which gives me a positive 2.25. And I'm going to add that to the first set of parentheses and the second set because they had the same b. On the right side, I've got to add 2.25 twice. Because if these were different numbers, I'd add both of, this was like a plus 4 and this was a plus 16, I'd do plus 4 and plus 16, right? I just added the same number twice, but I got to do it on the right side as well. Does that make sense? Okay, so let's get this straightened up. So I have x squared minus 3x plus 2.25 plus y squared minus 3y plus 2.25 equals 20 plus 2.25 plus 2.25 is 24.5. So these aren't very pretty perfect square trinomials with the decimals and whatnot, but they're still perfect square trinomials, and we know how to factor perfect square trinomials, right? So a perfect square trinomial is going to be two identical factors, so we just make one set of parentheses and square it. For my first set, what is my sign going to be? Minus. What's my first term? X. What's my last term? 1.5. 1.5, well, negative 1.5 quantity squared is what gave me 2.25, right? So I know 1.5 times 1.5 is 2.25, so the square root of 2.25 is 1.5. My next set of parentheses, my sign will be minus. First term is y, and again, this last term is the square root of 2.25, which is 1.5. So now, is this in general form? Yes. X minus h quantity squared plus y minus h quantity squared equals r squared. So my center is at h comma k. I have to change the sign of both h and the k. Where's the center? 1.5 comma 1.5. The radius is the square root of the constant, and that is not a perfect square. Yeah, 4.95. Now, so when I graph this, I'm going to round that up to approximately 5 because it's very close. But we have to realize that when we graph this, we've rounded that radius. So this is one of the potential problems of graphing. Sometimes when you round and you're graphing with freehand, it's not going to be perfect, right? So let's just go ahead and see what we have. And the radius is at a decimal, so we have to estimate that as well. So this is a prime example of when graphing is not the best way to solve this, okay? Sometimes algebraically is the best way. So let's go ahead and graph our center. When x is at 1.5, positive 1.5, y is at positive 1.5. My radius is just a little less than 5 units, and I'm at a halfway mark, so I got to be careful. So that's 1, 2, 3, 4, 5. A little less, it's hard to do. I'm going to go up 5. 1, 2, 3, 4, 5. To the left, 1, 2, 3, 4, 5. And down, 1, 2, 3, 4, 5. Now last time when we plotted those points, 2 of them landed right on the line, right? This time that doesn't happen. So if we really need a compass to draw this, we really do. I'm going to tell you that this circle is going to touch the graph at -2 comma -2, so that and that's the only place it's going to touch it, so that when you draw your circle, make sure it intersects there. Yeah. Approximately, an approximate sign. So it's going to intersect one time. So when you do your circle, but if I didn't tell it, oh, that's a terrible circle. Woo, terrible circle. But if I didn't tell you that, and we don't have a compass, that's going to be really hard to determine, right? Yeah, so if this is the method that you choose to use, you better make sure you have a compass. On the first one, it didn't matter so much because it landed right on the line. So that was a lot easier, but this one didn't. So we had to rely on our perfect circle. That was far from it. Only way we knew is because I told you. So I know I've said this multiple times, but y'all see why graphing is not always ideal. What would we say if this line and this circle only intersect in that one place? Tangent. We talked about that yesterday? Yeah. So the line's tangent to the circle at -2, -2. Coolio? Okay. So tomorrow, when I give you an assignment with several examples on it, I'm going to have you solve them algebraically. But I wanted you to have this in your notes for the main reason is to know how to graph a circle and to convert it into general form. That's mostly why I want it in your notes for future classes, know how to do that. But tomorrow, we'll solve them all algebraically. Okay? Algebraically, yes. Okay? All right, so we have a new section on the lined paper. I forgot to write down what topic. It's section 5. I forget what topic it's from. But it's not topic 10. And this is, we're still solving systems. This time we're going to be with quadratics. And we're going to do one that is a quadratic and a line, quadratic function, a linear function, and then we're going to do another one that's a quadratic function and a quadratic function. So on the left side, I like how this has main ideas / questions. When we do the first one, it's going to be a quadratic and a linear system. And then the next one we do is going to be a quadratic and a quadratic, because when I see you next class and I give you the assignment, we're going to have 3 different types of problems, 10 altogether. One of the types is going to be circle and line. The other type is going to be quadratic and a line. And the other type is going to be a quadratic and a quadratic. Okay, so you'll obviously want your notes to be able to help you because you solve them all differently. If you weren't here last class, make sure you get those notes before next class because you're going to need to know how to do that for our assignment on Thursday. All right, this first one is a word problem. Everybody loves word problems. All right, NASA launched a model rocket from the grounds of Cape Canaveral. The height in feet of the rocket with respect to time. Can be modeled by the function h of x equals negative x squared plus 10x, where x is time in seconds. At the same time, comma, a Navy fleet shot a laser beam from a deck 14 feet above sea level. The laser beam follows a straight path represented by the equation g of x equals negative x plus 14, period. At what height, and I'm going to make that plural because it could be heights, could be more than one, and time or times, will the rocket and laser beam cross paths? So I have a rocket, a model rocket being launched. It's a quadratic. We know it's going to open down because A is negative, right? So if I graphed it, it's going to look something like this. And the laser beam is being shot from 14 feet above sea level, and it has a negative slope. It makes a line, okay? So I want to know when they're going to cross paths. So basically, I want to know when each function's equal to each other. So can I make a system of equations to figure out what points they have in common? Why, yes I can. One of them's a quadratic function, one of them's a linear function. We haven't done quadratic and linear before. We've done two linear functions, not today or yesterday, but earlier in the semester. Remember, we solved those either using substitution, elimination, or graphing, right? Yesterday we did a circle and a line, and today we are doing a parabola and a line, okay? So first thing we would do is let's set up this system. The quadratic system was h of x equals negative x squared plus 10x. And the laser beam was that linear function, which they gave us g of x equals negative x plus 14. So I want to find when function h is equal to function g. So we're going to do this a little bit differently than we did a circle and a line, okay? I want to find when function h is equal to function g. We did this sometimes when we used substitution to solve linear equations. We got them both, we isolated the y, and then we set what the y's were equal to each other. We're doing the same thing here, substitution. okay? I want to know when function h is equal to function g. So substitute what function h is equal to, and substitute what function g is equal to. And then see what you got. What's my highest degree? What? Squared, right? So my highest degree is a 2. That means quadratic. Do we know how to solve quadratics? Yeah, we can either factor. That doesn't always work. Quadratic formula, that always works. Completing the square, that always works. If I factor or use the quadratic formula, I got to get it set equal to 0, right? If I complete the square, I want my constant on one side, everything else on the other. Well, I'm going to try to factor first, see if that works. So I need to get it set equal to 0, and I need my term with the leading coefficient to be positive. So I'm going to move everything over to the right so that that will become positive. Is everybody okay with that? All right. And it doesn't have a like term, so I'm going to kind of put it over to the side. And then I'll subtract 10x. So that 0 equals, I want to put it in standard form. Only like terms I have over here are the negative x and the negative 10x. My highest degree is 2. That doesn't have a like term, so I'll write it first. What's negative x minus 10x? Negative 11x. And then I don't have any like terms for the constant. Constants always go last. So I want to factor it. Does it have a GCF? No. Okay, let me think about this in my head real quick because I don't have a lot of space. I would need two numbers that multiply to get AC, which is 14, add to get negative 11. We got 7 and 2, 14 and 1, negative 7, negative 2, negative 14, negative 1. Is that going to be factorable? No. So I don't even need to go through the hassle. But does that mean I can't solve it? No, it just means I can't solve it by factoring, right? Not everything's factorable. So if you want to complete the square, you do you. I would prefer to do the quadratic formula. All right? So I know that A is 1, B is negative 11, C is 14. And I definitely know the quadratic formula by this point. X equals negative B plus or minus square root B squared minus 4AC all over 2A. Yeah. All right, so X equals the opposite of B. If B's negative 11, that's going to turn into positive 11 plus or minus the square root of whatever B is, square it. So it's negative 11 quantity squared minus 4 times A is 1 times C is 14 all over 2A is 2 times 1. Okay, so let me simplify that. I have X equals 11 plus or minus the square root of negative 11 quantity squared is positive 121. I'll do the minus 4AC all together. Negative 4 times positive 1 is negative 4. Negative 4 times positive 14 is negative 56 or minus 56. All over 2 times 1 is 2. So that's X equals 11 plus or minus the square root of 65 all over 2. If I were just solving the quadratic formula, I would want to simplify the radical as much as I can and then leave it like that. However, I'm looking for time in seconds and height and feet. I don't want to leave this as a radical, right? That does not really help me that much. So don't even worry about simplifying the radical if there's any perfect squares. Just turn it into a decimal at that point. Do y'all know how to turn a radical into a decimal? Put it in the calculator, right? 65, hit the radical sign. and at least round it to the nearest tenths or hundredths. Don't round it to a whole number, at least to the nearest tenths or hundredths. I know the square root of 64 is 8, right? So it's going to be 8 point something. When I put it in my calculator, I get 8.06 if I round to the nearest hundredths place. So 11 plus or minus 8.06 all over 2. Some of you are just putting the last number over 2. The whole numerator is being divided by 2.
I got 9.0.
Square root of 65 is 8.06. Divide that by 2. 4.03. Oh wait, I didn't mean to divide that by 2 yet. I just meant to do the square root of 65. Is 8.06225774. Okay. So now I'm going to separate that into 2 separate pieces so I can simplify it further. So I have 11 plus 8.06 quantity divided by 2, and I have 11 minus 8.06 quantity divided by 2. Simplify your numerator first before you divide. So 11 plus 18.06 is 19.06. Divide that by 2, and x is approximately 9.5. And I said approximately because I had to round the square root of 65. So that's not an exact answer, that's an approximate answer. Now on the other side, 11 minus 8.06 is 2.94. Divide that by 2, and x is approximately 1.4. Remember, x was your time in seconds. So this laser beam is going to cross paths with the model rocket 2 times. That's not an ordered pair. That's 2 values of x, right? An ordered pair has an x and a y. I found 2 values of x, so I know it's going to intersect 2 times. So that's my time in seconds. How do I find at what height they intersect?
You plug in the x
To where?
into the equation.
Which one?
The first one. Original one.
Either original. Either one. Okay? Now, when I always make my notes before I teach, and I wasn't thinking, and I was just thinking because we've been doing quadratics so much, so I went and substituted it into the quadratic. I'm not graphing this quadratic right here. That's what was formed when I combined these 2 functions together. I just wasn't thinking and did that. So make sure you don't make that same mistake. You have to go back to the original. It doesn't matter which original, but it cannot be this quadratic that we made by combining them together. Okay? So I would go probably to the linear function g in this case, just because it's less work, but you could plug it into function h and get the same answer. It's just the linear one's going to be less work than the quadratic one. Okay? Oops. And like I said, I'm going to use function g. Bless you. So the laser beam and the model rocket will intersect 2 times. It'll intersect at 9.5 seconds at a height of 4.5 feet. And it will also intersect in 1.4 seconds at a height of 12.6 feet. So it'll first intersect in 1.4 seconds at 12.6. So that must be when it's going up. And then when it starts coming back down at 9.5 seconds, because the feet are lower, so that's after it started coming back down. So obviously it doesn't have to be a word problem to solve a system of a quadratic and linear equation. Okay? Just be a quadratic linear equation. You would do the same thing. Little different than when you had a line and a circle. This is a quadratic and a line. Anybody have any questions before we move on? All right, example 2, backside. I'm going to go ahead and turn it. If anybody needs my paper when I'm finished, then you're more than welcome to borrow it. Okay? Solve the system algebraically. I have f of x equals x squared minus 2x minus 5, and I have g of x equals negative 2x squared plus 5x plus 1. So do I have a circle and a line and a parabola, parabola and a parabola, circle and a circle, line and a line? What do I have? 2 parabolas, right? They're both quadratic functions. Quadratic make parabolas. So I want to know when these 2 parabolas intersect, if they intersect. So this kind of system is a quadratic and a quadratic. So when I give you your assignment, when you had 2 quadratics, you'll know, go in your notes, look for quadratic to help you solve this type of system. Okay? So we do this pretty similar to what we did on the front side with a line and a quadratic. I want to know when function f is equal to function g. Okay? So I'm going to say, when is function f equal to function g? What order pairs do they have that are the same on both graphs? So I'll substitute what function f is equal to. Equals, I'll substitute what function g is equal to. It's our highest degree in this whole thing. Right, 2 degrees, right? So if we got all our terms combined, our highest possible degree we're going to have is going to be a 2. Unless that term canceled out. But that's our highest possible. Do we know how to solve a quadratic function? Yeah, so I'm going to get it set equal to 0 and go from there. Since I want my highest degree, I want that leading coefficient to be positive, I'm going to take this, I'm going to move everything over to the left, so that, because right now that's negative, and if I subtract that, it's still going to be negative. So I'm going to move it all to the left, and I'm going to do it all in one step. Okay? So and I'm going to line my like terms up. So if my signs are correct on the right, everything should cancel so that we're just left with a 0 on the right side. On the left side, I lined my like terms up. I need to combine them. Positive x squared and 2x squared make what? 3x squared. Negative 2x minus 5x make, and it's negative, right? Negative 7x. Negative 5 and negative 1 make negative 6. All right, so I can try to factor. If not, quadratic formula or completing the square. Let me think in my head. I would need two numbers that multiply together to get negative 18, add to get negative 7. Is that possible? All right, let's factor, right? If not, complete the square, quadratic formula. So if we're going to try to factor, is there a GCF? No. So let's identify A, B, and C. A is 3. B is negative 7. C is negative 6. Make my little T-chart. I need two numbers that multiply together to give me A times C. A times C is negative 18. And they need to add together to give me B, which is negative 7. Okay, let's give it a whirl. Negative 9 times positive 2 is negative 18. Negative 9 plus 2 is negative 7. Is it factorable? Yep. So we make our two sets of parentheses. The variable being used is x, so that's going to be my first term in each set. And then I look at my T-chart to see what the second term in each set is. I got a negative 9 and a positive 2. Am I going to have to divide and slide on this one? Yes, because A is some number other than 1. So I'll try to divide. If I can't divide, I'll reduce and slide. X minus 9/3, divide or slide? Divide. So what's my new factor? X minus 3. X plus 2/3, divide or slide? Can I reduce? No. So if I slide the 3 on over, what's my new factor? 3x plus 2. So I'm completely factored, but have I solved? No. So I set each factor equal to 0 and solve for x. If I set x minus 3 equal to 0, what does x equal? 3. If I set 3x plus 2 equal to 0, subtract 2, divide by 3, what does x equal? Negative 2/3. Have I found the ordered pairs where these two quadratics intersect? No. How many times are they going to intersect? Twice. I have found the x values of where they intersect, right? But an ordered pair has an x and a y. So what do I do now? Plug it in, plug it in. Does it matter which original equation that I choose? No, they're both quadratics. I choose either one. Do not choose the quadratic that we made by combining them together, okay? So substitute both x values into either original equation and solve for y. So I'm going to choose function f just because this leading coefficient's not negative. You can choose function g. Just be very careful about that negative coefficient. Y'all don't need me for this. You'll probably want to see my fraction math, don't you? I'll find a thin pen. So negative 2/3 quantity squared, I got 4/9. I did that, I'll show my math over here. Negative 2/3 quantity squared means negative 2/3 times negative 2/3. You multiply fractions, numerator times numerator, denominator times denominator. That's how I got 4/9. And then negative 2 times negative 2/3. I turn the negative 2 into a fraction by putting it a 1 over a 1 multiplied by negative 2/3. Negative 2 times negative 2 is positive 4. 1 times 3 is 3. So that's how I got the 4/3 minus 5. And then I work left to right, so I have to add these two fractions together. 4/9 plus 4/3. I have to get a common denominator, which will be 9. And the top fraction, the denominator did not change, so the numerator won't. The bottom, I multiplied the bottom by 3 to get 9, so I have to multiply the 4 by 3, and that's 12. So 4 plus 12 is 16/9, and that does not reduce. Just added two fractions together. 4/9 plus 4/3 is 16/9 minus 5. So again, to subtract that, I'm going to have to get a common denominator. So 16/9 minus 5 over 1. I'm going to turn it into a fraction. Common denominator is 9. The top fraction, the denominator didn't change, so the numerator won't change. And the bottom fraction, to make equivalent, 1 times what is 9? Well, 1 times 9 is 9. So I'd have to multiply the top, the numerator, by the same thing to make them equivalent. So negative 5 times 9 is negative 45. So now I can subtract them because they have common denominators. So 16 minus 45 is negative 29. The denominator remains 9. Or if I turn that into a mixed number, it would be negative 9 goes into 29 3 times with 2 remaining, denominator of 9. So one of the solutions was 3 comma negative 2. The other solution is negative 2/3 comma negative 3 and 2/9. So those quadratics intersected 2 times. So if I were to graph that, they would look something like this. Okay? They would intersect 2 times. So when you have 2 quadratics, they're either going to intersect 2 times, 0 times, or 1 time. If it was 1 time, one would open up, one would open down, and the only point they would have in common is their vertex. If they don't intersect at all, one's going to open up, one's going to open down, no vertex in common, nothing in common. But this one had 2 points in common, so we know they would look something like that. We have to actually graph them. Do we know how to graph quadratics? Could we go through that, graph both of those on the same graph, and figure out what points they have in common? Yeah, but we're just going to do it algebraically today. Is everybody cool with that? Okay, I'm going to pause the video. If you need to see my notes, I will let you see them after I pause. I'm going to do that first, and then I'll go from there.